Hello students, now today we are going to discuss Laplace transform of a integration of a function. So previous class we have already discussed the basics of Laplace transform. So how to find the Laplace transform of a given function. So now today we are going to discuss Laplace transform of integration of a functions. Already I told you when we are going to find out the Laplace transform of a derivative of functions. So now Laplace transform of f of t is nothing but what, that is your f of s. So any time domain function can be converted into a frequency domain by means of s. If time domain t is given, so how to find out the s domain, like time domain converted into frequency domain by the help of the Laplace transform. Already I told you the basics of Laplace transform. When you are going to Laplace transform of going to find out the Laplace transform of a given function, a time domain function, there is a standard formula to, that is your what, that is 0 to infinite, that is your f of t into e to the power minus st dt. So this is nothing but a standard formula to find out the Laplace transform of any function, that is your f of t. If f of t is given, so we can find out f of s by means of Laplace transform, and the formula is 0 to infinite f of t into e to the minus st dt. So now previous lecture video already I told you the Laplace transform of a derivative of functions. So Laplace transform of derivative function is what? So if Laplace transform of f of t is your what, that is your f of s, then Laplace transform of a derivative of function means what? So Laplace transform of f dash t, or we can say d by dt of f of t. So d by dt of f of t is nothing but what, that Laplace transform of f dash t. And what is the Laplace transform of f dash t? That is your s into f of s minus f of 0. This is the initial value. So this is that part already I told you in your previous lecture. So how to find out the Laplace transform of derivative functions? Suppose a time domain function is given, so you have to find out the derivative of that time domain function. Again, you have to convert it into the Laplace transform. Now today, the Laplace transform of integration of a functions. Laplace transform of integration of functions, that is what? Like is your derivative of a Laplace transform. So Laplace transform of derivative function d by dt of f of t, this is nothing but is your s f of s f of 0. Similarly, the Laplace transform of a integration of a function, like what? Laplace transform of a integration of a function. So integration, suppose let 0 to infinite f of t into dt. So this is your integration of a time domain function. So how to calculate the Laplace transform of integration of a functions? So 0 to infinite f of t dt, and the formula is what? That is your f of s by s plus f of 0, that is your initial value, by s. This is your Laplace transform of integration of a functions. The Laplace transform of derivative function, like what? S into f of s minus f of 0. But in case of Laplace transform of integration of functions, like 0 to infinite f of t dt equal to f of s by s plus f of 0 by s. This is your what? Laplace transform of a integration of a functions. For example, if I'll ask you, so find the Laplace transform, there is an suppose for example, if I will say find the Laplace transform of cos omega t, find the Laplace transform of cos omega t if the Laplace transform of sin omega t equal to say omega by what, that is your a square plus omega square. Already I told you that is your Laplace transform of a sin omega t, that is your omega by a square plus omega square. Find the Laplace transform of cos omega t if Laplace transform of sin omega t is given using the derivative functions, using the Laplace transform of a derivative find the Laplace transform of cos omega t if you know that if sin omega t Laplace transform is equal to omega by a square plus omega square, using Laplace transform by a derivative of a function. Like what? Already I told you what is how to find out the Laplace transform of cos omega t. But you know that Laplace transform of cos omega t, that is your s by a square plus omega square. But the question will ask you to find the Laplace transform of cos omega t with the help of the derivative of a function or maybe integration of a function. So how you will do, that is your what? That is your, already you know that Laplace transform of f of t, as you know that, is your f of s, and Laplace transform of f dash t, Laplace transform of f dash t is your what? That is your s f of s minus f of 0. F of 0 is your initial value. Here f of t is given, f of t is your sin omega t. This is given. If f of t is your sin omega t, f dash t is your how much? F dash t means derivative of f of t is your f dash t, and derivative of sin omega t is nothing but is your omega sin omega t. So omega cos omega t. Omega cos omega t. Derivative of Laplace transform of sin omega t is nothing but sin omega t derivative is nothing but cos omega t with respect to omega t, that is your omega f of t sin omega t, then derivative of that function is your omega cos omega t. So now if f of dash t is your omega cos omega t, so that is your Laplace transform of f dash t is your what? Omega cos omega t is nothing but is your s f of s. F of s, if f of t is your sin omega t, and if you get the Laplace transform, that is your what? Omega by s square plus omega square. Laplace transform of sin omega t, that is your omega by s square plus omega square. Using derivative of a Laplace transform, so that is your Laplace transform f dash t, that is your s f of s minus f of 0. So f dash t is nothing but omega by omega cos omega t, and s into f of s is nothing but omega by s square plus omega square minus f of 0. If f of t is your sin omega t, if t equal to 0, f of 0 is nothing but your 0, sin 0 0. F of 0 is your what? That is your 0. That is your s into omega by s square plus omega square. From this expression, you can find out the Laplace transform of cos omega t is nothing but what? Here omega that will be cancel out. Laplace transform of cos omega t is nothing but your what? S by s square plus omega square. So in this way also you can find out the Laplace transform of cos omega t rather than with the help of your conventional method, using 0 to infinity f of t into e to the minus st dt. By using derivative of a Laplace transform, you can find out the Laplace transform of what? If f of t is given and you can find out the f dash t, then you can find out the Laplace transform of a particular function using derivative of a Laplace transform. So now, so this is all about your what? Laplace transform of derivative. Or similarly, if cos omega t is given, Laplace transform of cos omega t is your s by s square plus omega square. If the question will ask how to find out the Laplace transform of sin omega t with the help of derivative of a Laplace transform. As usual process, you can find out Laplace from this Laplace transform of f dash t is your s f of s minus f of 0, f dash t. If sin cos omega t is given, cos of derivative of cos function is nothing but what? Minus sin of that function minus sin omega t minus omega sin omega t. In place of f dash t, you will put minus omega sin omega t equal to s into f of s. If f of t is your cos omega sin omega t cos omega t, and f dash t is nothing but is your what? F of s is your s by s square plus omega square. In this way also you can find out the Laplace transform of sin omega t with the help of derivative of a Laplace transform. Now next one is your what? In Laplace transform, another two theorem is there. There is your one is your initial value theorem and final value theorem. Initial value theorem. Initial value theorem. What is initial value theorem? In initial value theorem, if Laplace transform of f of t is your f of s, we can say that f of t, f of s as your Laplace transform pair. Means what? If Laplace transform of f of t is your f of s, then inverse Laplace transform of f of s is nothing but f of t. And initial value theorem says that and Laplace transform of f of t is your f of s. Initial value is nothing but what? F of 0. F of 0 equal to limit s tends to infinite s f of s. This is nothing but is your what? Initial value theorem as far as Laplace transform is concerned. When you are going to analyze a transients network theory like your resistor, inductor, capacitors, and if the network consists of inductor, capacitor or inductor resistors like that, either there is an initial value and final value. In inductor, inductor and capacitors, initially the capacitor will not charge. After some time interval, it will take some time to get charged. So charging and discharging, there are so many problems related to transients. They like your resistor, inductor, capacitors frequently will apply the initial value theorem and final value theorem. In case of initial value theorem, says that initial value f of 0 equal to limit s tends to infinite s f of s. How to prove it? So as far as proof is concerned, that is your what? Already you know that Laplace transform of f of t is your f of s, and there is a standard formula, that is your what? 0 to infinite f of t into e to the power minus st dt. This is your Laplace transform of f of t. If we say Laplace transform of f dash t, Laplace transform of derivative of function is nothing but what? That is your s f of s minus f of 0. Laplace transform of f dash t is how much? So Laplace transform of f dash t is nothing but what? When you are going to find out the Laplace transform of f dash t, what is the formula? That is your 0 to infinite. When you will find out the Laplace transform of f dash t means what? That function into e to the minus st dt. So that's why that is your f dash t into e to the power minus st dt is equal to, that is your s f of s minus f of 0. So that is your what? So if we say 0 to infinite f dash t into e to the minus st dt, if I'll say when limit s tends to infinite, when limit s tends to infinite, e to the power minus st is how much? That is your s tends to infinite means e to the power minus infinite. E p to the power minus infinite is nothing but 1 by e to the power infinite, that is your 1 by infinite, and the value will be 0. So if t tends to infinite, or s tends to infinite, that is e to the power minus infinite is nothing but 1 by e to the power infinite, that is your 1 by infinite, that is 0. If limit s tends to infinite, that value becomes 0. So take limit s tends to infinite to both LHS and RHS. What happens? If s tends to infinite, that value becomes 0 because e to the power minus infinite, that will be 0. So 0 equal to, that is your what? Limit s tends to infinite s f of s minus f of 0, or initial value, that is your f of 0 equal to what? That is your limit s tends to infinite s f of s. It is very, very important as far as initial value theorem is concerned, as far as the Laplace transform is concerned. When you will suddenly you require some initial value or final value, you can use this formula. Initial value, say at t equal to 0, f of 0 equal to limit s tends to infinite s f of s. Similarly, another one is your final value theorem. In final value theorem, like as you know that Laplace f of t and f of s are Laplace transform pair. So then what? That is your in final value, as in initial value, that is your f of 0. In case of final value, that is your f of infinite. One is your t tends to 0 and t tends to infinite. If final value f of infinite, there is a formula limit s tends to 0, that is your s f of s, okay, minus f of infinite. Like is your initial value, the limit is nothing but what? In previous slide, what? As far as initial value 0 is concerned, limit s tends to infinite. In case of final value, that is your what? Limit s tends to 0. So final value means at t tends to infinite. Initial value means what? T tends to 0. So now we will prove it. Same thing, if Laplace transform of f of t, that is your f of s, and the basic standard formula of Laplace transform, that is your 0 to infinite f of t into e to the power minus st dt. So in case of derivative of that function f dash t, that is your what? S f of s, s f of s minus f of 0. So then Laplace transform f dash t, and the formula is what? That is your 0 to infinite, that value f dash t into e to the power minus st dt equal to s f of s minus f of 0. Okay, then what we'll do? As you know that in case of previous case, in case of initial value theorem, that is what? T tends to 0. But in case of final value theorem, t tends to infinite. But in case of final value theorem, when t tends to 0, left hand limit to what? If t tends to 0 means if t tends to 0 or s tends to 0, limit if s tends to 0, e to the power minus st tends to 1. So like in your previous case initial value theorem, in case of initial value theorem, apply s tends to infinite to both LHS and RHS, but in case of final value theorem, reverse, that is your s tends to 0. There are two conditions. In case of initial value, take the limit s tends to infinite to get the initial value f of 0, but in case of final value theorem, take the limit s tends to 0 both LHS and RHS. If limit s tends to 0, that value is what? E to the power minus st becomes 1, and the left hand limit, that is what? Left hand side must be what? That is your 0 to infinite, that is your what? F dash t into dt equal to limit s tends to 0, that is your s f of s minus f of 0. Is not it? So take the limit s tends to 0 both LHS and RHS. Take limit s tends to 0 both left hand side LHS and RHS. Okay, and the step becomes what? F dash t, this will be 1, f dash t dt equal to limit s tends to 0, s f of s minus f of 0, and f dash t dt, that is what? F dash t dt derivative and integration. So that is what? That is your f dash t, that is your what? F dash t, this is nothing but f of infinity minus f of 0. So that is your what? F of infinite this value, that is what? Upper limit is your f of that is your t, dt integration t, derivative integration, that is your f of infinite minus f of 0 and equal to, that is your limit s tends to 0, s f of s minus f of 0, and this will be cancelled out, and here therefore f of infinite equal to, that is your limit s tends to 0, s f of s. So that is what? In case of final value, f of infinite equal to limit s tends to 0, f of s. But in case of initial value, f of 0 equal to limit s tends to infinite, s f of s. In case of initial value, s tends to infinite. In case of final value, that is your what? That is s tends to 0. So thank you. Next class we will do more and more number of numericals related to initial value and final value theorem. Thank you.